So welcome to the AT Construction Podcast. We have Neil back again. So welcome, Neil.
Thank you for having me, Brad.
Yeah, excited to have you on. So Neil Freidberg is the building science manager for LP. We've had him on, and Neil is an expert in building science. We spoke about that on our last episode, and I know you've been out here to Phoenix with us, and you travel all over the country, and you're back home in Nashville right now at headquarters.
I am enjoying our new facilities.
Yeah, so let's talk about that maybe first. I understand that LP just moved into a new facility in Nashville. And by the way, I love Nashville. It's a great place.
Yeah, so we previously had a different facility, but due to the way that the market has changed with COVID, we're in a kind of a hybrid schedule corporate-wise. So we take a couple days on and then work a couple days at home. So it's been actually really great to experience some together time with a bunch of people you work with rather than on screen.
That's interesting. So maybe really quick, I mean, because you're more corporate, right? I look at this, for me running a company, I'm managing 16 employees or 17 of us. So we're a little bit smaller, but in the corporate world, it's different. How have you seen LP kind of adjust just you as an employee, right? As you mentioned, this hybrid where it's part in the office and part working from home.
Yeah, so I think for the corporate, it's been mainly that. Obviously, home office people like the salespeople have been fine from the beginning. But like the lab that I manage, where we would do a lot of the experiments, all of the inventions, they've been in person the whole time, right? Because that's where their job is. But from us, from like a company perspective, it's been great. We've been equally as productive remote for the couple of years that we were. And now, being face to face, it's just easier to get someone, where they are. It's like, hey, can I talk to you rather than having to set up a meeting? So it's been really good.
As an employee, and this is maybe important for like the employers that are managing people, and I think in construction it can be tough to have people working remote at times just because there's a lot of like one-on-one communication and, a lot of us are in the field, so you can't really be remote managing a project. Do you feel as an employee, though, is there benefit to having that hybrid where you have both? I mean, how does that change maybe your motivation, from the employee perspective?
Sure. So from like my perspective and what I'm hearing from like, my employees or even other coworkers is they really have enjoyed the whole work from home, even this hybrid situation where we come in a couple days, we knock out as much work as possible in groups, and then everything else is kind of remote and you still have those meetings. But, we've been able to maintain tasks, finish projects, and do everything we need to. And for me, it's nice when I'm at home, I can go pick up my son from school. So, I get to work that into my day.
And do you ever wonder, especially managing people, the accountability side? I mean, part of this is you have to empower, you have to have good people, know they're committed to the brand. But from an accountability, do you find people more productive? Is that a challenge to manage their productivity?
From my case, as far as managing, not so much because all the stuff is in the lab anyway, so they were there the whole time. But overall, I've never had an issue with one of my employees or even some of my coworkers where I have to get on them on do work. It's typically, I'm playing catch up because I'm on, I'll get focused on one product or one project and I'll put a little bit on the back burner and not to shift myself. But overall, I think this has been a great experience for me in the corporate world.
I love that, Neil. Well, the main reason I want to bring you on is because, building science continues to be at the forefront of dialogue, right? I'm seeing this more and more from clients that become more interested, that are more savvy, they're following stuff online. You've been in this industry your whole life, your whole career essentially in the building science. What are you seeing from your side as far as demand from the public, which is really important for us builders and designers to architects to really become familiar with building science and, sustainability because of client demand? Like, what are you seeing from your side?
Yeah, so on my side, I'm seeing a shift from looking at buildings and walls as like a single product, right? Even though that it's great that you think of one product when you're looking at inside of a wall, whether it be the insulation, the studs, the sheathing, the house wrap, the facade. Most homeowners will see the inside paint texture, the outside facade. They never think about what's inside. But what's been happening more lately, especially with social media, is you're starting to get these little like microcosms, as I call them, like where you see a post online, someone saying, "Oh my God, look at my wall, it failed." And as a building scientist, I'm looking for the root cause. Naturally, everyone else is like, "Oh God, it's terrible," right? They go to the extreme, and I'm over here going, I'm like, "Why did it fail? How did it fail?" And that kind of leads them into looking into, right? So the person who like finds it, wants to get educated, starts leading into that path where they're like, okay, let's figure out kind of the root cause, but then what failed, how it failed. And what we're seeing as an industry is we're seeing this dynamic shift from looking at products themselves and as a system, right? Because the insulation won't work if the structure isn't airtight, isn't done well, and the structure won't last if you don't have a good way to protect it from external weather conditions or internal HVAC issues, right? So if you have a house and you've oversized it, it can get really cold really fast, but then leave a lot of moisture in that air, right? So then you're just uncomfortable. So you have to keep dropping down that temperature. But that moisture that's in there is being driven typically in from the exterior also, right? So it could be some moisture and vapor form from the wall through the exterior. So we have to look at buildings no longer as single components, but as a whole system, right? Because once you turn on that HVAC unit and you're living inside of it, you're opening doors, you're shutting doors, opening windows, taking showers, cooking, you actually start affecting the way that whole building operates.
I love that you shared that, because I think one of my challenges as a builder, and I think a lot of builders can relate, is that, one of the benefits of like Pinterest and Houzz and Instagram, you get these amazing pictures and it inspires, clients for the design. And, the client wants the beautiful range and cabinetry, but it's hard for them to really grasp, at least some of them. I've been with, the value of as you mentioned, like talking about moisture control in the house, good insulation, the mechanical design. I mean, all these components to figure out, okay, are waterproof, how tight is the house? Having that conversation a little bit different to say, okay, there's investment to do this, but trying to sell them, maybe not sell them, but educate them on the benefit of a well-built structure as opposed to just beautiful finishes.
Yeah, absolutely. I think I maybe mentioned this last time, or I've said it before, but no one ever says, I'm going to change my insulation in my wall one day, right? Like, they're not going to open up the wall just to change the insulation, right? They're going to change their cabinets, the countertops, all that. And that's great, right? You want to spend that money to make it look good, right? You want a house that looks good, feels good. But if you're not actually spending that time and effort looking into a good system for your climate zone, for the building, for your HVAC unit, you're really just making it look pretty, but it may not last at full length, right? We're starting to look at these homes and say, hey, I no longer want it to last the 50 year that they're typically designed. I want it to be one of these homes that last 100, 200 years now. Well, you can't get there if all you're doing is focusing on the prettiness of the interior without looking at the structure of the walls, the bones, right? This home is going to hold things together, and you want to make sure it performs as it needs to.
What's interesting, I think, and maybe this is a culture thing. You look in parts of Europe and like Germany, for instance, and they're building homes that are going to last a long time. Like, this is what they care about, hundreds of years. And unfortunately, in the U.S., we're a pretty wasteful society here. And so we're building stuff that's like very temporary. There's a lot of builders that come in and they're just putting stuff up, to be in and out. Longevity, how do we kind of move the industry to understand, as a culture probably, and just as a nation, to be more proactive as we're seeing other countries throughout the world?
Yeah, so that's great. One of the questions that I like to ask people when they ask me that question is, what has affected you to build better, right? Are you building to codes, right? So codes is a great standard, but it's the bare minimum, right? So it's some states are modified 2009, some states are 2021. So it depends on where they're building. But if they're building the code, they're giving you the bare minimum. But like with a builder like you, who's looking at like great systems that are going to make these buildings last a long time, you're going to get a different understanding of how that building works, right? Because you care about the HVAC system, but you also care about where that moisture is coming from. If you have I know you're in an arid climate, and I get that, but like if you were building in a humid climate, that moisture coming through penetrations, perforations, or some sort of air leakage paths actually do equate to quite a bit of energy you need to consume to recondition that air, right? So when you're looking at the codes themselves, there's a minimum. You always want to exceed that, but when you're looking at the builders in general across the nation, you're seeing that they're being now driven by like homeowner expectation, what they want. Homeowners want better homes. Homeowners are looking to get this value. And I don't disagree. The buildings in Europe are really built to last, right? Some of those walls are like 14, 15 inches thick. Ours are 2x4, 2x6, depending on your climate.
Yeah.
So when we look at that, that's what's driven by code. But there's programs out there like Energy Star that help drive towards that. Passive House that really drive towards that standard of air tightness, low energy consumption homes, but being very comfortable. So there's a couple things out there that help people get to where they want to be as far as like the home, but they don't always, I guess, have the knowledge or be able to do the research to do that. And that's kind of why I exist, right? I kind of make that bridge between like our materials. Yeah, we sell products, but when we sell products now, we're looking at a building solution, right? We're not looking at a individual material. Yes, we have the OSB, but that OSB with a WRB, WeatherLogic, is a struck one board that can help in seismic areas and high wind areas like Florida. And it's also a WRB with our tape and the liquid flash system that we have for it, right? So it's kind of like an all-in-one, right? So when you take care of the structure, the envelope, you're getting these homes that can become above or exceed code.
I love that you shared that, and we'll get into kind of some of the materials and building solutions, especially like with the, weather resistant barrier and stuff that you're doing. But what's interesting, Neil, is you mentioned that, some builders, like maybe this altruistic, mentality that hopefully every builder is going to be like, we want to build better and better, as far as more sustainable. Well, it can be difficult to achieve, right? Because we understand like the nuance of building, but the reality is there are some market driven things that are happening, right? We're seeing certain states, from California and like Florida is a good example where they're dealing with this massive issue with Ian that's coming through. And, like in a lot of parts of Florida where they can't even build wood frame, it has to be masonry just to protect because they know what they're up against, right? These storms happen. And so there's regulations, and you mentioned that there's a building minimum. But really what it comes down to is, yes, there are some people behind the scenes, such as yourself, that are helping drive the industry, but the consumers are going to really demand this too. As the consumers will become more educated, that's kind of going to force us builders to really learn about building science and really change our brain and really understand what we're putting in a home. How have you seen, just from your side, you mentioned this early on, that, by studying buildings, how they fail, this is now training you and, your product development to say, okay, we're seeing how they fail. How can we fix this? I look at this in my career that like just not building related, but the mistakes I've made have been really impactful to me running a business to say, well, I'm not going to do that again, right? I'm going to fix this. So how have those, we'll call them failures, maybe not you at LP, but just in general, building failures that happen, you're inspecting and saying, okay, I think we have a solution to this now.
Yeah. So, while failures in the field during buildings, it's the worst experience for the homeowner, right? And I empathize with them. But from a learning standpoint, it's huge, right? We get to see how it failed, where it works, right? So part of the things that I do is I make sure that the products we develop are specific to climate zones, right? So while we would love to just say, hey, look, we have this product that can be placed everywhere in every situation, that's just not true, because you cannot defeat physics. Physics will always dominate that conversation. But what we do is we hone in areas that say, hey, look, CI is becoming a big, continuous insulation is starting to be looked at a lot of places, not just in areas that are cold, but also code is starting to drive some of that south, right? So what builders are now looking at is saying, okay, well, I need to put insulation on my exterior, and then they have to start picking out which one. But not all of them work the same, right? Or like, for example, in Texas, we had a big group of people come into Texas. They came from the north, and they started putting a vapor barrier on the interior side of the wall. Well, in Texas, a majority of our moisture is driven from the outside in, so it just caused a condensation area for that vapor to get stuck and start failing walls, right? It would condensate on the gypsum, it would start rotting wood, right? So when you look at the buildings, I get to help guide, as far as the company, what path we go down using building science, using modeling, and using practical application processes. And while failures stink, that's how we learn as an industry. I mean, on another note, fire, right? So NFPA 285 came due to a fire, right? So foam plastic under if I remember correctly, a stucco finish. So in Vegas, that fire spread was very damaging to not just the building, but it injured and killed a lot of people. So that drove code. And that's why we have to be very careful when we're looking at these items, right? And that's why I can no longer look at just our product. We have to look at how it's done, right? So let's say you go with a commodity OSB, but you're using some of our smart side. What kind of house wrap? Are you in a climate that needs drainage, a drainage plane or some sort of rain screen, right? So these conversations are starting to happen even within our own sales group. That way they can start understanding what they need to do for their customers alone.
So let me ask you this, and maybe we'll touch on this climate zone, because I'm sure a lot of people listening may have heard the term climate zone. They don't understand. I know a lot of clients I speak to, most of us understand that, hey, weather in Phoenix is different to San Diego, is different to Florida, to Oregon, as opposed to the Midwest or, right, the Northeast. So you have these different climate zones without going into specifics, because most people can probably look that up. But in general, there's a rating, right? There's a number system to the climate zone. What does that mean, from low to high in general, just to educate the audience here?
Yeah, so so if we just look at the map of the U.S., we're divided into really three big sections: A, B, and C. So A is moist and humid, B is dry, and C is marine. So marine is much more coastal, like California. A is kind of the East Coast, and then Midwest, Central is the combination of moist and dry. And then we have numbers from 1 all the way to 8. So if you divide them into subsections, our current code says we have 19 climate zones now, right? So when you're looking at that, you have to understand how you're building to that climate zone. And then also you have to look at previous codes, because in 2012, the IECC map that was used for quite a while doesn't have Texas having any climate zone 1, kind of like Miami. Well, in the 2012. And then 2021, the new one is that Texas has almost like a climate zone, like a Miami now, at the very end of Texas, right? So you as a builder have to start thinking of, like, how is my building not just now going to be working, but then long term, right? So as you have these shifts in the climate map, which do affect your climate, how are you going to build something that is resilient through those changes?
And what does that come down to? I mean, to really understand this, whether it's a consumer listening, a potential client, or even a builder, designer, architect, as you're thinking about this, how does humidity, maybe building somewhere such as Austin or Miami, or coastal, like in the Bay Area of California, as opposed to in Phoenix, how does that dictate just the building envelope and really the products we're using?
Yeah, so it really should dominate the conversation when you're talking about building a home, right? So when you're looking at like a Miami or Texas, Corpus Christi, Houston, you're looking at this pressure from the Gulf that is pushing that moisture through your materials, right? Through your OSB, through your house wrap, through your insulation, through your gypsum. It's penetrating through there in vapor. So it's a slow process, sure, but it does affect the comfort in the home. So people tend to make it colder because their units are oversized. But when it comes to like in a dry climate, we have to look at where that moisture is coming from, because it's typically not driven from the outside. It's driven from the inside, right? So how long do you shower? How long do you run your exhaust fan? And while those same items still affect the areas that are humid, they're typically not as much of a concern as when the outside pressure, like if you're living off the Gulf Coast, there's plenty of people who have to go to like a very low perm or vapor retarder off that coastal, off the Gulf Coast, because of that pressure, that massive pressure of moisture just trying to penetrate through. But as you come inland, you can start relaxing off that vapor tight on the exterior and start looking at something that becomes much more vapor open, right? So it really starts affecting the way you build and everywhere, right?
This is why I love speaking to you, Neil. Like, you're such a wealth of information, and you explain it so clearly that, like, anyone that's listening is like, this makes sense, right? I mean, it's amazing, the education level and knowledge that you have, that you've put together. So just commend you for that. But what's interesting as well is not just from the moisture standpoint, but also you'll see from a code side, if you're building Charleston, South Carolina, like you can't, if you're on the coast, you can't build on the first floor, right? Because as we're seeing in Florida, these storms coming through, you have to be elevated. You can have like garage space, but not like livable square footage. Similarly, I've seen on coastal areas, I've seen how the salt, right? So the salt that's in the air, how that can have an issue on the substrates and the exterior facade materials. How does that play a role as well? Just thinking of, like, I'm not dealing with a ton of salt in my hair in Phoenix, but, maybe dust more than anything. How does that play a role as well?
Yeah, no, it's huge, right? And this is why I'm a big advocate of making buildings super tight and properly ventilating them. But like things like that, right? So salt air can be very corrosive to the building, right? So you're looking at this system. You want this building to last a long time, but if it finds a path where it can come in to bring in that salty, moist air, it can find screws, nail heads, right, and start corroding them, and then it really starts affecting your structure overall in the future, right? So when we're talking about that 100-year home, we want to make sure that you're taking care of the things that need to be taken care of properly, right? And there's systems out there with low perm tapes, liquid flashing systems that exist for builders, right? I mean, even we came out with one because we know that it does affect it. But when we're looking at not just the coast, we're also looking at other items, right? So like I think last time we spoke, I talked about the microclimates that happen in the areas when you bring in like a lake in an arid system, right? Those houses surrounding there all of a sudden have a high moisture pressure being driven inside, causing potential mold issues in stucco homes, right? But when you look at like further out or further into the high desert where they're not doing that in like Arizona, all of a sudden you don't have to worry about these things. You just have to more concentrate on making sure that you're not overusing moisture inside your home, right? Making sure you run your exhaust fan, using your building like it should be used.
So let me ask you this. I mean, you mentioned the bringing lakes into like arid climates, and like in Arizona, there are pockets of Arizona where you have man-made reservoirs, man-made lakes. They're pretty big. They're like ski lakes, right? And these homes back up to it. Can that affect, the moisture as well as mold issues potentially doing a stucco home near a body of water such as that in Phoenix?
Yeah. So, well, I can't state any specific studies. There are studies out there that have looked at the homes directly surrounding lakes versus the ones that are further out, right? And that moisture that evaporates, right? So it's constantly evaporating due to the cycle of moisture, right? Moisture evaporates and it starts going up. But some of that could be driven through the wind, pressure onto that building, and all of a sudden you have a much more moist surface. And because stuccos are cementitious products are typically porous, they tend to absorb some of that stuff, and they can hold it, and then they can, there could be a path in if you're not careful with the proper nailing patterns, the proper sealing patterns. So, when we look at the systems in general, we want to make sure that we're identifying all potential failures.
So as you're thinking about this through design, I mean, what you're speaking about, I mean, it's so complex, right? It's just mind-blowing the amount of information and detail that we have to know. And as a builder, we're mitigating and managing risk all day. Like that's what we're doing. And we want to build things that'll last. We want to think down the line, not just building homes that are sustainable, but also protecting us from like mold or issues, that could harm our clients one day. As you're seeing, especially now because of social media and, the network that's out there, people can hire architects and designers from all over the country to work remotely. It's pretty easy with Zoom and, through Instagram, they've built a following. How important is it for an architect to find local engineers or consultants in that area? Do you recommend that just because, as you've been speaking about the last few minutes here about climate zones and impact just based on so many variables, in each area of the country?
No, it's huge. So I always recommend having somebody local to help kind of set those guidelines. You can reach out to manufacturers if you have concerns or questions, right? So if someone said, hey, I want to use some of LP's products like our WeatherLogic or our new insulating CI system, NovaCore, right? So if they want to look at systems like that and they have concerns, we have the capabilities to help guide them, make recommendations based on where they're building. So they can be designing from anywhere, but building to that climate, right? So that's one of the best things about manufacturers is I'm not the only building scientist in a manufacturing site, right? They're all going down that path, right? You can go talk to an insulation company. They're going to have a building scientist. A rain screen company, they're going to have a building scientist that's going to be looking at how to specifically identify the building you want, what you want to achieve, and how, and kind of the products that they can recommend from them to get you there.
So let's talk about that. I mean, because LP's done a great job. They have, their structural solutions, and they have a vast array of product. They have, the NovaCore you mentioned, the top-notch WeatherLogic Legacy FlameBlock, and TechShield. What's interesting is, as Neil, we're doing Mark LaLibrete's house, a net zero house here in Cave Creek, and he's actually using FlameBlock, TechShield, Legacy, and WeatherLogic. Like, we have those four. We're using.
Yeah.
Maybe walk through each of those products. You mentioned NovaCore. Are any of these products, we mentioned 6 of them, are they area specific, geographic specific? Can they be used everywhere? How does that, correlate with the R&D you're doing there in the lab back in Nashville?
Yeah, absolutely. So right now, out of all those products that you mentioned, there's only one that is kind of location specific, TechShield. In the colder climates, we want to kind of avoid that due to the phenomena of internal snow. But like when you're looking at
what is that? What is internal snow? I live in Phoenix, so I don't even know what that is.
Sure. So there's a phenomenon that occasionally can happen when you have a high moisture content in your attic, and you get this shift when, as the sun sets, all that heat starts escaping to the exterior. Right? It was being driven in. That humidity may be staying there. So as it drops temperature, you can actually get a snow inside your attic, right? So that vapor moisture starts coming together, bulking up, and then becoming actual snowflakes in your attic. So
that's incredible. I can't believe it. And maybe this is me being naive, but building in Phoenix, of course, and growing up in San Diego, I'm not a hockey player. I don't skate. I can't skate backwards. But even getting to the snow side, I'm not built for the snow. So just understanding, the ice potential, or the snow that can happen inside. I mean, that can be pretty consequential to a builder. Yeah,
correct. So TechShield is one of the things that we don't have in a lot of climate zones. It's in typically 1, 2, 3, and depending on your area, potentially 4. Not in the 5, 6, 7, 8. For that reason, well, not for the snow reason, but for the fact that there can be some condensation issues on the metallized surface. But as far as like Legacy, our flooring product, it can be pretty much anywhere. Our WeatherLogic, it qualifies for pretty much anywhere. NovaCore, the way we're installing it with foam in and OSB out, you will need a WRB, but that can pretty much be placed anywhere if you're designing the building right. So that is typically a conversation I'd like to have with a builder who decides to say, hey, I'm going to start using NovaCore. That's great. I want them to use NovaCore. I just want them to make sure that they're looking at all the aspects that include all the HVAC sizes that you may benefit from, a size reduction because you're reducing thermal bridging. That's less heat gain, heat loss due to that. But then you have our WeatherLogic that can pretty much go anywhere. We have a tape system now. We have that. We have the liquid applied. We also have the FlameBlock, right? So FlameBlock, it's a struck one board with a cementitious coating on a single side or double side, and it can be used great for fire. I like using it like when I talk to people who are building like an attached a shed, depending on HOA, stuff like that. I actually recommend FlameBlock for that. It's probably one of the better solutions because people in sheds tend to store things that can light, right?
Catch on fire.
Yeah. So that's a great way to protect your home and have a system that can defend itself, basically.
Before I do want to go down this road of the FlameBlock that we'll get back to in a minute, but maybe going back to your comment about the NovaCore, when you're thinking about NovaCore and WeatherLogic, would there be a reason to pick one over the other? I mean, walk through maybe not pros and cons, but just different application of why you'd use one as opposed to the other.
Yeah, sure. So it kind of just depends on what the builder wants to do or the homeowner wants to do, right? If you're not, if you're in an area like South Texas where there's no need for continuous insulation, this is a great product. But if you're in an area that recommends continuous insulation, but that's not the path you want to go, you can go to a thicker wall, or you can even go to like a thermally broken wall with double walls, stuff like that. But the benefit is you have a WRB attached to the OSB with WeatherLogic. And with NovaCore, you just have a commodity OSB where XPS is adhered to it, and it's foam in. So that's going to allow that builder to say, wrap it with whatever they want. If they need a vapor tight membrane, it can work great in the coastal areas because it doesn't it reduces that drive, right? But it also allows for that reduction in heat loss and heat gain through thermal bridging.
And so just to like explain this a little bit more to what you just stated, Neil. So when you're using like a NovaCore product, again, this is beneficial to like continuous insulation. As you're looking to thermally break the house all the way around, it's going to assist with that. Whereas WeatherLogic, has that OSB, but that WRB, and you can use like a liquid applied membrane, which is what we use, that the Desert Comfort experience. And then now you're fully enclosing kind of a one-stop shop. I'm putting my OSB, which is full shear that I'm doing on all my house, has a WRB, the weather, resistant barrier, liquid applied. Now I'm done. It's one step. I'm in and out.
Yeah, and that's really the benefit of it, right? It's for those people who need to come in, put OSB on, and then house wrap, and it works great. It's gone through all the qualifying testing necessary for high wind areas. While Florida is going to have to go through a rebuild process with a lot of that loss of property, I'm hoping that as that happens and they come in and rebuild, they're looking at more resilient products too. Right, that way it can help withstand some of these issues in the future. Because this isn't like one-time occurrence. I mean, it happens quite often.
Yeah, and we've seen that it happens. I mean, maybe not yearly to this level, but it's going to be recurring, as we know. So with the FlameBlock, and I love the example you gave that, especially like a shed or an ADU, or it could be any outsourced building. I know for Mark's house, he has a detached guest casita. So his detached guest casita is off the main house. It's roughly 1,000 square feet. We did like a ready frame product out there through Billa's First Source, which was really fun to do as my first ready frame. But because he backs up to the natural desert, the preserve, right? There's no one that will ever build behind him. It's protected desert. However, it's a dry arid climate. Fires can happen. And he's looking at this like, okay, how can I protect myself if a fire starts, especially this detached building that's near the desert right there, and hence the reason to FlameBlock. Now, with that, do you recommend, Neil, that people are doing FlameBlock for the exterior sheathing as well as interior? If you have interior sheathing, I mean, how, or just exterior, does it make a difference to have it on both sides of the wall?
No, depending on the construction style, right? So, like, if this was like, well, I think Mount Liberté, right?
Mark La Liberté, yep.
Mark.
Yeah, you're totally good.
Sorry. Mark's house. It's funny because I know him too. Mark's house is a threat from wildfires happening in such a dry arid climate. We can also look at things like that, right, where it can benefit that. Or maybe if you had like an internal kitchen area where you dealt with a lot of semi-commercial products, right? Because I know typically nicer homes don't go with the residential things you're looking at. They typically go to semi-commercial. So it would be a great way to say, hey, look, I have a butler's pantry with a full commercial kitchen, basically, and I can surround that with FlameBlock to help protect my house in case of fire in this area, right? To protect the rest of the home from fire spread. Or even in like multifamily or even townhouse or row houses, right? The separation wall, the exterior walls, or WUI zones, all these items is where we qualify, and we have a UL-rated structure for it.
So to that point, maybe specifically the benefit of FlameBlock, right? Like temperature-wise and maybe hour duration, if a fire starts. Is there beneficial? I mean, you could speak about those details, but in addition to that, you mentioned the kitchens. I've seen this. I have clients putting in more, advanced kitchens. I have one house doing 4 kitchens, right? I mean, they're not going to be full-size operating kitchens, but they're pretty substantial, and it's just the size of the home and the way they're setting up. But from a firewall, like in the garage where you could potentially have something in your garage, do you recommend putting FlameBlock there?
Yeah, absolutely. And anywhere that you want to keep something that can catch fire separate from within your own building, absolutely. It never hurts to have this stuff. You can line it underneath the gypsum, and it typically adds about 30 minutes per layer of, so if you have a double layer, that's about an hour. Single layer, that's about 30 minutes. But that 30 minutes can save your whole structure from collapse, right? That 30 minutes is going to get you and your family out safe. That 30 minutes is going to help extend the life of your building while the fire department's getting there to help put things out.
Yeah, and to that point, I mean, even 30 minutes, and as you mentioned, a double barrier gives you an hour. Most people, unless they're super remote, I mean, you're going to have someone there 10 minutes possibly, at the most, I mean, to put that out.
Exactly. Yeah.
Go ahead.
Yeah, so it's one of those things that for the remote people, it benefits them even more, right? And in areas in Texas where I used to live, I mean, a lot of the fire department was volunteer, and that still exists to this day. When you're around a big city, you typically actually have a brigade or a station that can actually help much faster, right? So for people who are much more remote, this is a great product, especially if they want to protect their property.
It's interesting. I visited Alaska many years ago. A friend of mine and his uncle was a firefighter, but same thing, volunteer, right? So some of those areas are volunteer. It may not be like here in Phoenix where it's municipality and it's, these guys are on call 24/7, but, just something to think about. Going back to the top notch and the legacy, probably similar to NovaCore and WeatherLogic, difference, pros, cons, how do those products vary as far as application?
Yeah, sure. So our TNG 350 is not a full MDI
Which
product.
TNG, tongue and groove for anyone that may not.
Yes. Sorry. So.
Oh no, you're good.
It's basically a self-spacing item. We have not just to help drainage during construction, and even with our legacy product, which is a full MDI product with Gorilla Glue technology inside of it, you're able to get a self-spacing product that's real high quality, right? It's one of the best products out there, in my opinion. I've been able to walk on homes and not be able to hear squeaks, which is huge to me because as a building scientist, I'm looking for absolutely everything. And so much so that I don't think any of my coworkers will ever invite me to their home. Let's just say that. Neil is shunned from ever visiting people's houses.
So real quick, if I interrupt you, I don't know if you're an Office fan. So I love The Office, right? And there's an episode where Dwight and Jim, they go to the corporate party at, anyways. And Dwight's doing a personal inspection of the house, asking how much it costs. But anyways, it just made me think that's probably Neil. You're not to call you Dwight, but you're there doing an inspection, checking the chimney, on the roof and everything, knocking on walls.
Yeah, maybe not that extreme, but yes, I notice absolutely everything. So I'm probably the builder's worst.
A blessing and a curse, right, of being in building.
Yeah, it truly is. You see everything from minor defects, from surface to, when you're walking, you can hear a knock or a crunch, and you're like, oh, let's be careful there.
So that's interesting. So one thing that drives me nuts, and I'm glad you brought this up, our floor squeaks, right? And so that's something that's always been a pet peeve of mine. And you'll see, without calling out any builders, but I mean, it's a tendency they're putting in that subfloor, and it's, this OSB that's really thin, and it's going to have issues. And especially as you're maybe on the elements over time, building takes time to frame, getting wet, like if you're in Oregon, how does that play a role, using something with the Gorilla Glue such as, Top Notch or Legacy?
Yeah, so it helps with the longevity of the construction, right? Because delays are naturally going to happen, right? It's building. If it was easy to build, everyone would do it. But it's not. You have to schedule. You have rain days. You have delays, right? So as you leave your wood exposed, it can start degrading. So what we do is we have a sanding warranty, and on top of that, because of the way we've done our tongue and grooves with those drainage areas, any water that's standing will naturally just continue to pour down. That being said, we obviously want stuff to get dry fast, right? And so as you maintain that building, as soon as you start putting sheathing on the roof deck and around the exterior, you start reducing the elements, but that allows that board to start drying in that condition, in that unconditioned space, basically, or that protected from element space, where people can open windows and let air come in, pulls out all that moisture from that. But one of the benefits of it is, we have an adhesive for those squeaks. We developed an adhesive. It increases the squeak warranty with our legacy product itself. But, another thing that I like to talk about is the bounce, right? So when people walk on floors, you tend to feel almost like sometimes you're in a still boat where you can kind of feel a bounce between the rafters, right? Or between the joists, the floor joist on products. So when you're looking at a high quality product, the thickness also matters, right?
I love that when you're thinking about the bounce or deflection, right? And especially the squeaking. I mean, these are major concerns that most of us have. And we've all been in that second floor of a house that maybe wasn't built very well, and you're walking, you hear the floor squeaks. There's nothing that'll drive us nuts more, right? As a builder and as a client, as you think about multifamily purposes, hotel, right? They're going to have different code regulations for a lightweight gypsum concrete, a gypcrete, that they're going to be putting down. We have a tendency to do that in a lot of our second floors or our floors over a basement here in Phoenix. Recommendation or value of, a legacy product, if you're using a lightweight gypcrete over the top.
Yeah, absolutely. There's even, there's companies out there that also make sound attenuating mats, right? You can put our legacy down to help with that stiffness to, elongate the life of that gypcrete, right? You don't want it cracking under a bounce or under a weak subfloor. So you can put a nice little impact resistant mat and then put that to level, I think it's great, right? Anything to help keep the longevity of your products that you see. And, you know, I say this, and for those who don't know, the gyp creep helps level everything out, right? Because you're going to get bone. You're going to get, you're going to get some, whether you nailed it just right or nailed it an eighth off, right? You're going to get discrepancies in the level. So that gyp creep helps build that. But you want that gyp creep also not to get failed or not to fail underneath it. So you want the substrate holding it. And this is what I mean. This is a great example where we're building something, right? You want a great subfloor to hold the gyp creep. So you can have those super thin finished tile flooring, right? Those large
format porcelain tiles.
Yeah, those large porcelain tiles.
Yeah, because to that point, no, what's interesting is, and we use that too, when we're doing the gypcrete, we're using like an impact mat or something in there, which helps like the durability of the gypcrete or lightweight concrete. But by having that stability, as you mentioned, with like a legacy product and then the gypcrete, and then now, and this is happening, like I'm having clients that are coming in and putting this huge format, 24 by 48, now bigger. I mean, everyone wants like less grout lines, less seams. We're seeing this in countertop material. So, I mean, the client demand's going this way. The manufacturer's now able to produce this stuff. And so you have to think about, like, if I'm installing full slabs in a shower, that's one thing. But on a floor, these massive pieces, if that floor's not level, if there's issues, especially on a second floor, you think about just the pressure points, cracking. And now that's a warranty issue for me or anybody, right?
Yeah, absolutely. And that's what I mean, right? So that's the flooring. And they walk on that every day, right? And the person underneath is going to hear that every day. So when we're looking at these advantages, you want to make sure you're building for what that homeowner wants. If they're looking for sound comfort matters too, right? Impact insulation class, when people are walking in heels above you, no one wants to hear that. So when we look at the building, I mean, we're looking at it whole.
So with all the R&D and these amazing products that are out there, we talked about all the LP structural solutions, going through these, client demand, for us, general contractors and others that are specifying this product and using it, how has your backlog been? And you may not be involved in all the production side. How's that been just with like limited supply chain and labor and freight and all things you're dealing with as a manufacturer to get that product out there, including the adhesive and tapes that you're using?
Yeah, no, that's right. So I don't have line of sight to any of that, which is one of the things that I kind of...
So it gets you off the hook. You don't get me calling you saying, Neil, where's my product, right?
Yeah, correct. I can't help you with that. What I can help you with is properly designing it for your clients, right?
And how often are you involved in that? I mean, do you ever consult with other third-party firms outside of LP, or are there people that you'd recommend as you're looking in, designing that building and that envelope and the layers, of the exterior? How involved are you in that with the architects and engineers in our markets?
So I guess it kind of just depends, right? So like I've worked with big builders, I've worked with little builders, and it's a combination of saying, hey, look, builder in Alabama, moisture is an issue when you have fiber cement on OSB. Let's look at something like our Smart Side product that's all OSB, because it can last longer. It can help reduce that moisture driven into your actual envelope. So these are the things that I work with. Well, I can't stamp something from an engineer's perspective. I can make recommendations, but I can do some high level analysis with or for the builder. So, and as far as, going back maybe to the building science side, because I did want to touch on this, you mentioned this earlier on the makeup air side. For those listening that don't understand what makeup air is or the purpose, buildings are getting tighter, as you mentioned. And as the building's tighter, walk us through makeup air, the purpose of it, and why we have that. Yeah, absolutely. So what happens is when you start building a tighter home, you start developing an increase of your breath or CO2. And that's what you don't want, right? So a high concentration of CO2 in a space will reduce the life of the occupancy depending on the parts per million, right? Once it starts exceeding a certain amount, it starts doing damage not just mentally but also physically to your lungs. So by having makeup air, you're bringing in fresh air, but then semi-conditioning it, throwing it into your conditioned space or into your HVAC unit, and then pulling some of that out, right? A lot of homes today aren't anywhere near as tight as where they can be, so they're kind of off the hook. But as we build tighter and better systems and homes, we need to start looking at that.
And how, when you say look at that, how important is it to really think about exhaust fans, large hood vents? We're doing these massive ranges, and the amount of CFM, right, at the hood liner that's pulling out. How does that impact just all the variables in the home for makeup air?
Well, huge, right? So one of the things that I always tell people when you have a big unit like this, look into a system that understands that you're turning on your big exhaust vent over your stove to where it can open up a damper to keep it balanced. Because all of a sudden you can cause a vacuum, right? All of a sudden your house goes from being positive pressure to negative pressure, which does damage to your HVAC unit, the actual variable speed blower in the HVAC unit itself. You can start wearing some of that. But if you have a way to balance it where it opens up something on the other end to help bring in moisture, bring in that mixed air, you're going to have a better performing home, right? More comfortable. And on top of that, you're not going to have to worry about struggling to open or shut doors when it's on.
We've all seen that, right? Like if the house isn't built right, to struggle to open door as soon as the return air or something's kicking on. Additionally, when you're thinking about makeup air, there's also, you have to think about the scuttle lid. Some of this is dependent by code, right? Attic access and scuttle lid. Traditionally, most of us think like, okay, the framer's going to block out an area. You have a piece of drywall that's sat there, but in these homes, as they get tighter, you can't have that same setup. You have to have a scuttle lid or attic access that is, built in place that can pop open, sealed, that can pop open because of negative pressure.
No, it's true. And on top of that, depending on how you build your house, whether it be vented or unvented, is, if it's unvented, you're going to get all that outside air just pouring right into that space, right? And that's going to make that whole area uncomfortable. But what that does is it adds moisture, adds load to the HVAC unit, to the building, right? So that moisture is going to be going somewhere. We don't know where. So we want to make sure by building a tight envelope and controlling our air, we can build a much better performing home.
So do you ever get, and maybe I may sidetrack you here, Neil, a little bit, but do you ever get involved in like the blower door tests? Like as far as those calculations as you're doing your lab work, is there a recommendation that builders should be achieving, for a rating on their blower door test now and, things they can do to help impact that more positively?
So I'm a little bit on the more extreme side. I think builders today, with all the technology, all the things that we can do today, builders can naturally get to about a 1.5 ACH50, right? If they actually put some thought into how to air seal, what to air seal, how to air seal. And if they ever want to have that conversation, I'd be more than happy to talk about it. I can nerd out all day.
That's what I figured. I figured you'd be a 1.5 guy, just for what it's worth.
I like the 1.5. I like an ERV, HRV. Depending on your climate zone, you could have a combination of both, maybe one or the other. But it's just one of those items that, we want to make sure that we control that conversation around air and indoor air quality. We don't want that leakage coming in through the wall because it can collect dust, it can collect other things that are unwanted, it can damage the structure, right? So moisture can come in through those same paths. We want to make sure we control it really well.
So when you talk about a builder, maybe they're stuck in this 2.5, 3.0, the air exchange, what's maybe some low-hanging fruit? What are some recommendations they could do to air seal, tighten the home, to be really, especially with all the technology and availability that's out there?
So while it's not something that's out there yet, I am currently working on some sort of system to incorporate into our products, right? So we have products, but I'm trying to build a system. So I want to build an airtight wall where, regardless of what the insulation is, right? Because people like to talk about spray foam, and spray foam has its place, but it doesn't air seal as well as people like to think. When we talk about a wall, it seals, it sprays inside that wall cavity, but only 3% of that wall is our joints, right? So, and it's not going to be able to spray between or behind studs, right? So the air is really tricky. So while you can say, oh, I'm going to deal with it with spray foam, yeah, you can, but it's not going to be as well controlled. So while I can't give you too many details, we are working on something, and as soon as we have, maybe we'll set up another one of these calls.
I love that because we're just getting to this point where I was going to say what's upcoming and exciting, and you've kind of dangled this carrot. So how soon can you have this ready for us to start implementing?
Potentially 3 months if everything works out right. We'll see.
That's amazing. And so with all the, again, I know we talked about this a little bit last time, But what's your outlet? Like, things that you're doing now, excited about, just, to keep you occupied because you're spending all this time in the building science, helping our industry. And, what do you do to re-energize and sharpen that saw?
Yeah, sure. So between, my hobbies, my many hobbies, from working on computers to woodworking, me and my family love to go hiking. We're very active. I have a 6-year-old son, and he's pretty much our world right now. So it's great. Family is pretty much where I get to relax.
I love that. And how about travel? Like, do you ever, any upcoming travel plans do you have?
Yeah. So we'll be going to Corpus to go visit my friend. So I moved from Texas to Tennessee. So I'm going to go back this month and go hang out with them for a while. So get to basically tour Texas again, say hi to family, and say hi to all the friends that I haven't seen in a while.
Yeah. Was that transition tough? I mean, moving from Texas to Nashville, it's not critically far, but it's still a huge change of culture and it's not close. So
yeah, it's about a 14-hour drive if you ever want to buckle down and do it in one day. But it's it's good. The people here are great. The people here I work with are great, and it really helps kind of that whole thing where my transition was easy. I tell you what, though, I miss the food. Texas had better food than Tennessee, and I stand by it. No ifs, ands, or buts.
Oh, better watch out for any Tennessee people. I bet and barbecue is probably much better, I imagine, in Texas, too.
Yes, it is. Memphis has really good barbecue, though. Not so much Nashville. Memphis. Nashville hot chicken, not bad. I like it.
Well, that's amazing. Well, Neil, you've been awesome. I mean, just your wealth of knowledge, as I mentioned earlier in the episode, it's incredible to hear you speak. I just get so energized when I speak with you. So for those listening, how can they find you? Yeah,
so I just have kind of a LinkedIn. Since our show, I did start a Instagram. Haven't posted anything else, but it's called BS with Neil.
BS with Neil. We're going to have to write that and make sure we tag you on there. So that's amazing. Well, Neil, I can't thank you enough for making time coming on today. We'll definitely follow along so that you can solve some of our ACH, blower door test issues that we have in the future with the new products you have coming.
Absolutely. Thank you for your time. Thank you for having me.